Hello everybody, today we will look at how to index and select data from a panda data frame. So for this purpose, first of all, I am going to create a data frame with some random integers in it. And first of all, I'm going to import the modules, import pandas pd, and I'm going to also use numpy as np. So now let us create a data frame with random integers. So first of all, we need we can supply in the data frame the values as a 10 by 4 matrix or an array. So we will create first of all 10 by 4 numpy array with random integers. So we use numpy.random.rand int, and if I say this is values, and if I look at the help of that, we can see that it takes a low and a high value. The low and high, the high value is not included. So let us say we want random integers from between 1 and 41. So we say 1, 41, and the size here is basically this is a shape. Like we can say 10 by 4, which would be our array. So let us create values equal to values. We said between 1 and 44, up to 1 to 40, or between 1 and 41. 41 is not included, and the shape is 10 by 4. So of course one more. So let me check again. So values equal to values, say 141 and 10 by 4. Okay, so this is what we have now. We have random integers from 1 to up to 1 to 40. Now we also need the column names. Say index, we can say we'll supply say A, B, C and D. And so now we can create our data frame df equal to pd.data frame, and first will be values, and we can say in columns. Oh, I mistyped it. It's okay, let me call it, it was supposed to be columns, just a variable name. So values, so we have column, my columns. So we got the data frame. So this is what we have. Now we can when we consider indexing, so we have basically 3 of them. We can use this for indexing, the square brackets, and we can also use log or iloc. So first we'll use this based indexing. All right, so we take the data frame, we can index, we can supply the column name, so which basically gives you a panda series. And we can of course get a data frame out of that. We can use this operator. So we got as the first column as a data frame. So if you use this, we get a series, and if you use this, we get a data frame. And of course we can pass in more column names. we can, if we want A and B, or say A and D, we got A and D. Now we can also, this is one way of indexing or selecting the data, and we can also use attributes. So I can say df A, or I can say df D. So this is also another way of selecting the data. Now let's move on to the log based selecting the data. So first of all, let me log is label based selection of data. So first of all, let me change this index values into, say, something like strings for the demonstration purpose first. So I say import string. Let me construct that. Say index. Earlier I messed up, so anyway, that's all right. Index equal to I can say list string dot ASCII letters, and let's select from, this is nothing, this basically gives us A, B, C, D, F, G strings. It gives you a string of A to Z as small letters and as A to Z as capital letters, all combined without any spaces. So I'm going to select it from A, B, C, D is already used. So I say from 4 onwards, and I need 10 for each of these rows. I'm going to use more letters. So I say 14. Now if I look at index, so this is what we get. So now I can just say, first of all, I make a copy of df1 is equal to df dot copy, so that my df is there. For later we can return back to it. Now we see, if I say df1 dot index equal to index. So now if I say df1, so I got, this is just for the demonstration purpose, because as I said, LOC, the log, I don't know, it's label based indexing, which means it chooses the labels as strings. Each of the indexes are considered as strings, A, B, C, D, or E, F, G, H, I, J, K. Everything is a label, a string based indexing in some sense. So let us start demonstrating that. So we can say log. So we are going to choose rows. Okay, so we say I can just do E. So I got pandas series, and similarly as earlier, we can also make it into the same into data frame. So the same thing, what we get here is the first row. Of course, I could choose, say, I can go from, I can just say, I can choose another row, say M and N. We could do that, or we can just say df1. We can choose from, we can go from, say, F to L. Of course, we need to, this is all. So we got F to L on the row side, right? So the point to remember, when I say F colon L, when I slice it, I am also getting L. So that is one thing to remember when you use label based indexing. We get the last letter, this L also is included. Now of course I can say I only want D, and I can again do the same way. I can cast into a series, so I am only getting D, and if I want more A and D, do that. So this is basically label based indexing. And now if we go back, so this is what we have, and here I can also both the first part and the second part can be a Boolean array or list, which basically means I can say in either of cases I can say true, false, false, and true. So this works. So we get same A and D. We just said true, false, false, and true. And also here also I can use 10, a Boolean of 10, a Boolean of 10 elements, a list of 10 or an array of 10 elements with the true, false kind of thing, and select E or F or G or whichever column you want. And so we know that if I say, if I can construct a Boolean like this, for df of, we are using df1, if I say greater than, this is say, just say greater than 15, so we get a Boolean. I can pass this here. I can say df1, I mean A greater than 15. So which means it will look here which one is greater than 15. So we won't get F, G, we wouldn't be getting I, you know. So these are the conditions here. So and now, so we have only these many elements, and of course this is because of here we are using this as well. Now I can also use any one-line function like a lambda function, a function with one variable, one argument. So I can pass that and get the same thing, because it basically returns back this Boolean. That's what's happening here. And here also I can pass a Boolean, whatever you like to. We could say df1.log of 0. Here say whichever, df log say E greater than 22 maybe. Greater than 22. So we only got line B. So we can use this as well. So we can use a slice, we can use a label, we can use a Boolean, or we can use a function, and that returns a Boolean, which will help us, which will produce the same effect as whatever is available as a label or a Boolean array or a list. So now, so we are looking at the label based indexing. So let us go back and look at this. So this label here, E, F, G, H, I can also use, let's go back to DF. So here there is 0, 1, 2, 3. Everything works exactly the same with label based indexing. Even I can use it here as well, which means I can say df.log, I can say 0. Remember, I'm using df, this is not df1. So same thing, and I can do that, and everything works exactly the same. And also if I say 0 and 9, I get that, and we can slice it. But the important thing is, if I slice it here, see, I am getting 0 and 9, up to 9. The 9 is also included. So this is taking it as a label, not as a number. That's the main thing. LOC, the log, it takes the parameter as considers the indexes and the column names as a label, not as a number. And the last the slice, the last element is also included. The 9 is also included here. So now let us go back to iloc, which is position or integer based selection. So now we use df1 in order df1, so we already has it. So here it's saying everything remains the same. So I can say df of 0. Okay. So I can say iloc. We are looking at iloc, which I can iloc 0, and I can say let us slice it up to 5. So you see, I'm not getting 5. Now it is taking as a number rather than as a label. So iloc is integer based or the number based. So if I don't get the last, I'm only getting up to 5. So basically 5 minus 1 up to 4. And we could also do the same thing as before. I can just say 0 and 5 alone. I can only pick up column D. Again, the error is because 5 means 4. 0, 1, 2, 3. So up to we have 3 elements. So it doesn't work because here we say again it's an integer base. That's why the error came. So again we can do, it's a data frame. I can put more than, I can pick up 0 and 3. And as again we can say booleans, true, false, false, and true. And we can pass a boolean in the first here as well. One of the things that I have noticed is that you may get into an error if you use the same thing as before. If I say df1 dot, so df dot, we can pass a boolean, say df dot, so df of say a greater than 15. If I say this, see, it says not implemented error. So this because this thing basically returns a pandas series. So but if you cast that as numpy dot array, this works. Or you can also cast as a list. So basically if you use a list, it will work. So the idea is to remember that for iloc we get into an error if you just pass a series for boolean, and we can just cast them into a list. Or we could just use a list. We can construct a boolean list by saying bool 10 is equal to, we can say x greater than 15 for x in df a. Say if I say bool 10, see, we can pass that to, we can say here So we can do that as well. And as said earlier, all of this can be functions which returns a boolean or any of those labels, a single one argument function. So what I'm saying, so here I could use a lambda, same thing. So df with df dot iloc. So df of a greater than 15. Again, we need to, this would again return a series, so we can make it as a list. So here also we could same use the booleans. So that is mainly about iloc. So we can use log or iloc in a similar fashion, but there are some errors you may get into which you can pass. If you pass as a array, boolean array, or a list, it really works well in either cases. So you can restrict yourself to use of that. So we can use this for indexing, or we can use log, or we can use iloc. Log is label based and this is integer based. So that's it. Thank you.